Hello, my name is Christian Sander. I'm a senior here at West Kentucky, majoring in data analytics, and I would like to present my employee retention project. As an introduction to my project, this presentation is going to be about the longstanding issue of a low retention rate in many companies today. With a data set that I found, and I will make a model that will hopefully accurately depict what attributes will play a significant role in an employee leaving, as well as a predictive model to predict if said employee will leave. Um, with a combination of numeric and nominal attributes, I can get this done, and all this data is performed using RapidMiner, and the data itself is found somewhere else using the website Kaggle. So first of all, before we can get started, we need a overview of the 7 steps of business analysis. So, step one of the 7 steps of business analysis is to have a business problem understanding. A problem is given to a business analyst like myself, and we determine how we can use data to fix that issue that is being brought up. Step two is data collection and understanding. Based on the problem at hand, we find data that we believe is most accurate and will be the most useful in our presentation and into solving that issue. Step three is data preparation and feature selection. So the data that we found in step two is cleaned, and then we use a variety of features to make it the most able to run. And also, we make some decisions on how we actually want the prediction to go. Step four is model development. We use a variety of different models and run them and see the results. And the results are shown in step five, um, which we can present some type of outcome and official prediction. Step six is the results and communication. So from the results of step four and step five, we run an analysis on which models performed the best, which one did not perform as well, and the different advantages of each model. And step seven, based on those different models and how much we tweak them, we will make a decision on which model we believe would be the most appropriate to implement and deploy for predictions. So, step one is the business problem understanding. So, why does a retention rate matter? So, in the year of 2023, is projected that 45 million employees left their current workplace, and nearly half of all workers were considering leaving their jobs at some point. This is from a source. Depending on the company, um, one um, one worker leaving can cause a massive problem for revenue, and their revenue can tank even if it's just one person. Furthermore, it can also create a unhealthy view of the company. If one person leaves, it could encourage other people to leave. So the business problem is important for executives and HR who want to retain a healthy and long-lasting workforce. And with the workers are happy and not wanting to leave, there's evidence to show that they will try harder and perform at most optimally. So step two is the understanding the data source. So from the website Kaggle, I found a employee future predictions, and as you can see, this is it in Excel form. It is a 4,653 different examples with 9 different attributes. And some of them are nominal or strings, such as the city and the education, while some are numeric, such as age and payment tier. And right away, we see what we want, and that would be leave or not. That would be our dependent variable in this. And then lastly, to mention that this is considered a secondary data source because I did not collect this data myself. This was found from a secondary source, hence secondary. So first off, what we do is we take the data that we got from Kaggle, and then we put it into RapidMiner. On the left, we can see what it actually looks like in RapidMiner form. It is basically the same as the Excel sheet, just different because it is in a different software. And we can also put that into a blank sheet in RapidMiner, as you can see with that little box right there. And this will be the baseline of everything that we do. This is the data. So secondly, for step three, we need to what's called set a role, and setting a role in short will tell RapidMiner that what our dependent variable is. And so the dependent variable is leave or not. We made that clear in step two. And so in order to do this, we do the set role operator function in RapidMiner. And then in that, we tell that this is the attribute we want, leave or not, and we put it as a label. And when we run it, we can see the highlight in green shows that what I did is exactly what I wanted. Green shows that leave or not is the focus in this. The next step for step three is the nominal to numeric. So we are taking the string values that are not a number, so city, education, ever benched, or gender, and we're putting that into a way of coding. So a number of a one or a negative one. And this is how we do that is we do the nominal to numeric. We put all the attributes that are strings, so city, education, every bench, and then we use a what's called a comparison group as as a way to turn them into numbers. So as you can see with we make sure that we it is exactly how we're using the values that are presented. So example, we're using gender as male, ever benched as no, education bachelor's, and city as a Bangalore, and see from the um, the data on the right, we can see that all of those attributes are changed and it changed into numbers, and then that we can find, and then we can move on. So, starting off, what we are going to do is we're also going to change our special attribute or dependent variable, which is leave or not, into what's called a binomial. Because right now it is classified as a one or a zero, but that doesn't. We need to make sure it's a true or false actually, because that is what the one or zero is actually wanting to do. But we have to tell RapidMiner to do that. So using the operator numerical to binomial. Send the attribute to leave or not. When we run that, we can see it is exactly what we needed. So on the right, you can see that the instead of a one or a zero, it is a false or a true. And just to confirm, we run it and we see that it is shown both in the chart and in the actual statistics. Moving on, what we need to do is sampling the data. So as you can see in the previous step, there are much more false values than there are true values. And so we want to set it to an equal amount. And we use that by sampling. So we take the sample operator, put it to true or false, and select it to both 1600. And once we run it, we can see that both true and false have 1600 variables. So we actually lowered the number of examples to 3200. Next up, we can move on to step four, which is our model development. And the first thing we need to do for model development is split our data. So we're going to split them in training and testing. We obviously want to train the model we're using and then put that training into the test into a testing to actually test how we did with our model. So the majority of the data is going to be in training, and the minority will be in testing. So rule of thumb, usually it's around 75 to 25, but here just started with 80-20 just to see how we're doing. And this is going to be the most tweaked way to improve accuracy into our model that we can be testing. So using the split data operator, we changed the ratio to 0.8 and 0.2, so 80% for training and 20% for testing respectively. And once we run it, we can see that on the left, which is training, there are more examples. 80% of the data, 80% of the 3,200 that we had is in training, and then the other on the right is 650. So there are more training attributes than there are testing, which is exactly what we want. So next up is the actual model development. And here, the most simple model to use and will be a good ballpark figure will be the logistic regression. So we take the split data. So you can see here, there are two pars here. And the first one is the training. So we put the training into the logistic regression operator. We take the second one into the apply model and then take the logistic regression, put it into the apply model, attach performance, and then the attach apply model. And so all of this will, which the training model will train in the logistic regression, and then with the apply model, it will apply what it is trained on the remaining data. So 80% of data goes to the logistic regression train, and then based on their training, it will go to the testing data, which is 20%. And then using the performance operator here, we can eventually see the results. So once we run it, we see the first box at the top here, we can actually see how it did. And as you can see, the first row predicted it was this person was going to leave, and it was true. Second one, it was false, but the prediction was actually true. So in order to get as you can see, there are a variety of numbers and numbers here. So what we need to do is to figure it out, we go to our performance and it creates a nice little chart for us. So overall accuracy is 69.38%. But what we're really looking at is the recall, or what's called true, or the true trues, which is 77.81%. That's going to be the main thing we use. So overall, not bad. However, we can compare it. So we're going to use an ROC model, which it puts all the true truths on a y value, and then the false truths on an x value. You can see it's a chart here. And then, so using the compare ROCs, we put our model in there. We put our logistic model in the compare ROCs, and then the chart will show. And the red line is the ROC, the is the ROC, and then the AUC is the blue line. And as you can see, what makes a good ROC is to be straight and upright. The logistic regression model is kind of lacking in that, so there is a clear incentive for us to do better. Last thing of note here before we tweak the model, we can see our p-values. P-values will show the most significant attributes so long as it is above 5% or 0.05. So these are a list of different attributes, and I highlighted the ones that were not statistically significant because it did not cross that threshold of 5%. So city equals Bangalore, education, PhD, experience, and age all were above 5%, so not statistically significant. 5% is usually the rule of thumb. It can be lower, it can be higher, but 5% is what we're going to use. So, and now we can start actually tweaking the logistic regression model. And so a common fix that we use for it is that we readjust the training and testing um, split ratio. And for how I wanted to do it is I wanted to use one higher and one lower. So the first chart here is at 85% training and 15% testing. It did better. It did much better in especially in recall, where it's at 84%. But I also wanted to test one lower, which would be 70% training and 30% testing. And the true trues was 85.62%, which is very, very high. So that is based on it, and since recall is the one we're going to use, that is the model that I'm going to compare it to. Next up, so we have our ideal logistic regression model, which would be the 70-30 split between training and testing. But we can also test different models to see how they will be used and how they compare against the logistic regression model. This by ROCs, so the true truths and the false truths. Even though this is a very, very good system, it will not always accurately show recall. So they still need to be tested and the performance need to be shown to make sure that they're actually correct. But this is a very cool system to use, especially to determine what model would be the most optimal and to at least go into model model training and model testing to see which one is the most effective. So we're going to use the auto model in Rapid Miner for this, and it will determine the best ROCs. We start the process by taking the employee data and multiplying it into an Excel sheet. We then take that Excel sheet and put it into the auto model. So this is a copy of the original Kaggle Excel sheet, and we just put that into the auto model. Next up, what we do is we select the task now that we selected the data. So we put predict because we want it to predict, and then we put leave or not because that is what we've been testing. Next up, we want to select turn into classification because we are classifying it into either true they are leaving or false they are not leaving. So when we do that, we put it also into the inputs as well. So we make sure that every attribute is used to make sure that we get just accurate models. Next up, we just this is where we can select models, and we're basically putting all model types on blast and seeing which one is the most optimal. So as you can see here, this is actually a comparison of all the ROCs that are being used in the ROC chart. It can be hard to see, but the ones that I decided to use, which are up in the highest, is a random forest in the red, and then the deep learning model in the green. So they're the about one in the first and second, or just the very highest. So now we are going to start testing new models. So basically, it was pretty easy. All I did was just replace the logistic regression model and change it to deep forest and or deep learning and random forest, respectively, and did the same type of connections in it. And we're going to use the same split data of 70-30 because that is what worked the best. That is what worked the best. So as you can see here, these are the results for the new model. So the results for deep learning, the accuracy improved. The logistic regression was about 67%. This is about 81%. However, the recall of true truths that did not improve. It was slightly worse, and then the logistical regression model of 85.62%. And also it is the same story for the random forest. So both deep learning and random forest did not improve the recall, which is what we really, really wanted to determine. So therefore, the ROC was not entirely accurate. It was accurate in determining the overall accuracy, but what we want to test, which is recall, it was not accurate in that assumption. Okay, so next up is the model evaluation and interpretation. So this is again a list of the chart here of the logistic regression model, which based on the attributes of recall is the best model that we wanted to use. So the recall and sensitivity, what we really want to check was 85.62%, so the highest out of both both logistical regression models as well as the deep learning and random forest. So that's why we chose it. Recall is also called sensitivity as well, and the specificity, which would be predicted false and was false. See the number here of 241 was at 49.79%. So not the best, not the best if we're looking at specificity. Predicted false was true was at 38%, and then predicted true was false was at 0.21%. So it's a mixed bag here. However, what we're really determining, again, the recall or the sensitivity, so predicting true is true. The highest rate of 85.62. So we are going to go along with it. So step six is the results and communication again. We're going back to our p-values here as well to determine the significant attributes. So I already determined what were the insignificant attributes, which was age, experience in current domain, education, being a PhD, and a city equals Bangalore. Now, this is still from the original 80/20, but it was the same. It determined the same p-value, just in different numbers, but the significance remained the same. So, so what is actually significant here? Well, based on the numbers here and the 5% threshold, gender is a significant role. Your joining year, so when the company actually when the employee joined the company, is a significant attribute. The city, being in New Delhi, is a high and significant attribute. Your payment tier is high as well. Education, having a bachelor's, um, and being benched. These are all important factors that, as the results will show, it can determine. These are the most accurate ways to determine whether somebody will leave a company or they will stay. So what we can also do here to really test out as well. We can also do a decision tree, what's called a decision tree model. And what a decision tree will do, it will take these different attributes and then it will kind of work them into action, and you can see it in a tree form. So you have, for example, one of them was if gender, for example. So if a they can select gender. So if it's a male, it will make a tree. It will make two trees, one going to the left, one going to the right, and then it can be joining year. So if the employee is a female, joined in 2016, what are the chances of that specific whole group staying in the company? And you can get a better illustration of it both both in terms of visual and um, written form. So as you can see here, the and I made sure to take this specifically because the joining year. So if an employee joined after 2017 and their payment tier was high at a two or a three rather than a one, they were the most likely to leave. And you can see zero stayed and 255, all of them in that specific group. It was true that they left. So this that's a way of determining of showing both the decision tree in action as well as how it will show the results. So the next step here is the model deployment. So again, based on what we were looking for, which is our recall of true truths. So if it predicts true, we want it to actually be true. The logistic regression model with a 70% training and 30% testing was the overall best. It performed well out of both logistic regression models that were one of them was 80/20 and the other one was 85/15. This had the best overall recall compared to all of them, as well as the other models that I tested, which was the decision tree as well, which I didn't show the results, but it was lower. The random forest and deep learning. Um, we are sacrificing accuracy here. However, again, what we really want to determine is if we predict a true, we want it to actually be true. That is what I as a analyst, I believe that that is the most important part. So I'm willing to kind of make that call and sacrifice some accuracy so we get the overall best recall for true truths. And this model did it. It was the logistic regression model with a training and testing ratio of 70% and 30% respectively. So this is the model that I believe should be deployed. All right. So the conclusion here is so we have our model, which is the the logistic regression of a with a 70-30% training and testing. But we also are not going to forget about our p-values and the information that was given. So this is a reminder of what were the attributes that made a company leave or made employees leave the company. So it would the significant attributes was gender, joining year, the city being in New Delhi, the payment tier, having a bachelor's degree, and ever being benched. So these attributes are the most important when determining if somebody is an HR or somebody is an executive and they are looking at pools of candidates that they believe are most likely to leave. These are the most significant attributes because of the p-value at a confidence interval of 5% or lower than 5%. So these are the most significant attributes. And we can even go more into specific when we look at our decision tree model. We are also aware that we, based on our decision tree and what it was shown um, in in this with our decision tree, as we can see both in visual form and in written form, if a employee joined after 2017 and their payment tier is high, they are most likely to leave. So they are the most at-risk employees, and so more attention needs to be put onto that specific pool of employees, and that could be whether they're that could be a variety of things and things that our data cannot say. That could be work culture, that could be workload, that could just be overall employee satisfaction. But as a data analyst, I cannot necessarily tell you why. I can just tell you what is. So, as shown, um, employees after 2017 in a high payment tier are the most at risk to leave. And it could come to a variety of factors and factors that executives and decision makers have to make. I can't really make that decision. However, they're the most at risk at the moment, and so that could just be a better employee appreciation. That could be maybe pay raises. That could go come down to a whole variety of things. But at least for this specific data set, this is the most these type of workers. So joining after 2017 in the high payment tier are the most likely to leave, and most attention should be placed on that. Those are my conclusions, and with that, my um, my presentation is wrapped. Thank you so much.